Hello everyone, welcome to Calculus BC for lesson 33. This is where we're going to discuss integration by parts. So integration by parts is actually derived from the product rule, and the equation that we're going to use is right here. And what we actually end up doing for integration by parts is we integrate two functions that are usually being multiplied together. And so what we have to differentiate between is what is our u and our dv. So our starting point for integration by parts is the integration of two products. One we're going to represent or denote as u, and the other is going to be dv. Based on what we denote, and we have a strategy for which one is which, we're going to go ahead and follow out our formula based on, again, the product rule. So what is the u? What is the u? Well, one of the popular things that calculus teachers use is something called ILATE. So ILATE, I stands for inverse trig functions, L stands for log functions, A is algebraic, T is for trig, E is for exponential. The higher up on the list, the more likely it's going to be u. So if I had an inverse trig function being multiplied by an algebraic function, my u is going to be the inverse trig function. This is a great strategy for us to apply integration by parts. So let's look at an example and talk about what we need to do for this. So if we integrate x times cosine of x dx. Now, just like before, if I asked you guys to find the derivative of x cosine of x, you would have to use the product rule here, right? You can't just take the derivative of x, you can't take the derivative of cosine of x and call it a day. Well, the same thing applies to integrating two functions that are being multiplied together. You just can't integrate x and then integrate cosine and multiply those products together, those things together. So what we're going to end up doing here is we're going to look back at ILATE, and you guys can see that we have two functions. We have the x and we have the cosine of x. So we do not have an inverse trig function, we don't have a log function, we have an algebraic function. So we have an algebraic function and we have a trig function. So those are the two that we have here in this particular example. So a comes before t, so a is going to be your u. Then everything else in the integral is going to be the dv. All right, so let me actually write up for us again what the formula is. That's at the very top of the page, so we can kind of use that. I realize now as I'm writing these problems out that my u's and my v's look very similar to each other, so let me go back and write them more legibly. Okay, so that's better. So u is going to be x, so everything else in this integral is going to be dv. So over here, it's going to be cosine of x dx. And so I always set up a system, and I do u du v dv. And what we're going to now do is we're going to take the derivative of u, as we normally would to find du, and that's just going to be 1. And then we're going to integrate cosine of x to get v, right? In order, if I give you guys dv as cosine of x, well then v would be the antiderivative of this, which is going to be sine of x. And so we actually have all the information that we need to actually start solving this problem. So the integration of cosine of x times x dx is going to be equal to, and we're going to follow our formula here. So we're going to multiply u times v. So we're going to go x times the sine of x minus the integration of v, which is going to be sine of x, times du. And I should have written here 1 dx, right? Because we're taking the derivative of x with respect to x. So I should have that this is sine of x dx. And so this is now very easy for us to simplify because we just have to integrate now sine. So our final answer for this problem is going to be x sine x minus the integration of sine is going to be negative cosine. So we're going to go ahead and do minus a negative, which is plus a positive, cosine of x plus c. So that is a pretty simple, straightforward example for integration by parts. So let's try another example. Okay, so let's look at the integration of x e to the x dx. And as you guys can see, I went ahead and wrote down here ILATE and then the actual formula for integration by parts. So we have x, which is actually a algebraic function, and we have e to the x, which is an exponential function. So based on ilate, our u is going to be the one that's the furthest up in our ilate, so a. So again, in this case, u is going to be x. And then everything else in the integral is going to be our dv, right? Because again, we're integrating u dv. And this is derived again from the product rule. So this is going to be e to the x dx. We are going to do an example in a minute where our algebraic function is actually not the u. But just like before, we want to take the derivative of x. Well, we've already done that. This is 1 dx. And we want to integrate dv to get to v, which is just going to be the integration of e to the x, which is awesome. It's just e to the x. And, once you know the formula, this is actually not challenging at all because you can just plug in what you have. So again, we multiply u times v, which is going to be x e to the x. And then we're going to subtract the integration of v du. So e to the x times 1 dx. And so this is why this is actually a really awesome, system for us to do, because it's pretty awesome that this just leaves us with the integration of e to the x, which is just e to the x and then plus c. So the integration of x e to the x dx is x e to the x minus e to the x plus c. It's a lot of e to the x's there. So let's go to a little bit more challenging question now. Okay, so we're going to go ahead and look at example number 3, where we're integrating x natural log of x dx. So in this case, we have an algebraic function and we actually have a log function. So for the first time ever, we're going to make our u actually the natural log of x. And so I always like to write it, uv du and then dv here. And so dv is going to be everything else. So this is going to be x dx. So the natural log of x, we want to take the derivative of that, and that's going to give us 1 over x dx. And notice that right now, guys, these functions are very, very basic. We do get into more complicated things later on, but yeah, they're very simple to find the derivatives of. All right, so 1 over x dx. When we integrate x, because remember, to get to v, we have to integrate dv, we're going to get x squared over 2. All right, x squared over 2. And so just like in previous examples, we are good with this problem. Now all we have to do is just follow our equation here. So x natural log of x dx is going to be equal to u times v. So again, I always tell students it's just the top row multiplied together. So it's going to be 1/2 x squared natural log of x. So v times u in this case, minus, and it's always going to be these two things right here. So it's these two multiplied, and then you look at these two right here. So v is going to be x squared over 2 times 1 over x dx. So we just want to multiply this times this. Now, what really awesome thing happens in this example is that, first of all, I can pull out the 1/2, right? I can pull out the 1/2. And then this x is actually going to simplify with this x squared right here. So if I can just really quickly rewrite this over here as minus the integral, actually minus 1/2 the integral of x dx. So 1/2 x squared natural log of x minus 1/2 the integration of x dx. When you're doing integration by parts, you want to be able to get something over here that's pretty easy to integrate. Now in a future video, I'm going to show you guys, okay, what happens when this is not easily integratable. And we'll talk about that, like I said, in another video. But right now we have this. And our final answer, guys, is just simply going to be, and again, notice I'm just leaving this alone because there's nothing to do here. U and v, when you multiply these two things together, you don't do anything with them. And so the integration of x is going to be x squared over 2 plus c. And so we can finish this up by saying 1/2, if we want to just make this as clean as we possibly could, 1/2 x squared natural log of x minus 1/4 x squared plus c. So that's going to be our example for that. So we can do, I think that's a good one for right now. That's a good 3 videos, or three examples. And I will see you guys in the next video where we'll do some a little bit more complicated ones where we have to use some u sub. And then in the third video, I'll show you guys what to do when we can't integrate this particular part as easily as we've been doing so far. So I'll see you guys back in the next video.